Okay, live one more time. This will probably be a shorter stream, unless somebody jumps in and we get questions. After the last stream, I did some debugging and got it working. And we now have this little spacecraft because we managed to get the science, a couple of flights, and I ran a few of the missions. So what we got running was a mission sequencer, and we adjusted the persist mechanism bit. The mission sequencer is fairly simple. The core of it is next phase is basically, we'll start with go. When you tell the mission sequencer to start processing, it picks up a phase number from the persistent memory. Oops, here, and clamps it to one of the indexes into phase func, which is an array. So there's a phase func array, which is an array of function delegates. Phase in the persistent area will index into that, and that's the function to call for the next flight phase. And those functions are intended to run and terminate promptly. So we'll run phase 4 over and over and over and over again until phase 4 decides it's done, and it will then say next phase. So we grab it, we clamp it. I'm going to go ahead and store it back to persistent. Again, if I clamped it, this will store the corrected phase number. So for instance, if we had a plan of 15 entries and we rebooted and we only had 10 entries, this would do the 10th entry. So again, I folded all of this code together for compactness so I could see it on my screen easily. We grab the entry from the phase func array, indexing by phase number, and we call it. It's going to return a value in seconds, which is the time until the next call. We clamp that to 0 to 10, so if it returns less than 0, we're going to say 0. If it turns greater than 0, we're going to say 10. And then we're going to set our next mission event to now plus that far in the future. This is all inside a when, so this is a background asynchronous task that it's going to do. We return true, saying cycle it again, and the condition is when time is after the mission event time, which we just set, do it. So this will trigger at this next mission event. So for initialization, we just set it to current time plus 1 second. We have an abort flag that is initialized to false. Somebody might set it to true, and if they do, we exit. So there's our step function. There's our function that runs the mission plan. So to make this work, let's say I have a mission phase that's circularized. When it says it's circularized, it has to somehow bump phase number. And it does that by calling this next phase number, which is going to get the phase number and increment it and store it. So the next time we get back to go, it will bop around here and pick up, if it was phase 4, now it's phase 5. So initialization of this thing, where's add phase? Add phase is called with a phase name and a optional function delegate. And this is so that we can just name the phase, and if we name the phase, it's going to go find it. If we don't name it, okay, if we name it and give a delegate, we'll use the delegate. If we don't pass in a delegate, we'll go find it in phase of, and that goes onto the list. I was messing around with storing the name so that we could have a display saying entering circularization phase, entering descent phase, and so on, but that crufted up the logic a bit, so I left it out. We can add it later. So phase of is a more generic thing, and we'll see why in a moment. Normally it's going to be a string. So if it's a string, we're going to import phases and go get it. The reason why we can't import phases up atop is because phases, as we'll see in a moment, imports mission. And if I import you and you import me at the top, that means the first thing I do is I call import on you, and the first thing you do is call import on me, and that's not going to work because import doesn't return until the thing we're running returns. So you end up getting Stack Overflow. So instead, we defer doing it down here. Now, once we've imported it, that import call is going to return immediately. So the only time one of these would actually trigger a load from the archive would be if, for some reason, my mission didn't import phases at all. I'm wondering if perhaps I've got this reversed, if maybe mission should be lazy importing phases, if phases should be lazy importing mission. I don't know. Clearly one way or the other has to happen. But for now, where I use phases in this file, which I believe is just here, I will do the lazy import. The reason why I want to do this is we had this add phase that adds one phase, you give a name and a delegate. What if we want to pass in a list? Well, add phases, let's pass in a list. I'd like the list to be just the strings. I want to have delegates in there, but I don't want every entry in the list to be a string delegate pair. So what I do is it's a list that normally contains strings but might contain delegates. So we call add phase, and now we look at this and we say if the phase is a delegate, we use the delegate. So how is this called? If we wanted to do this, we might have something that says in here, print hello from delegate. Then mission, next phase. And that would work. Or I could even have my phase. So if my phase was a function that did the right things, I could put it in like that. But for most everything, as long as I have all of the stock mission phases in the phases package, we can write most of our code like this. We say add phases. The next thing is there's a background thing. So this covers do phase 1, phase 2, phase 3, phase 4, and so on. No subphases, no branching, no looping. It's just steps. And when you finish one step, you go on to the next. Background is a little different. Let's go back to mission. So BG, you call BG with a name and a delegate. And if the delegate isn't sent, we look up the name. So again, you can have a name and a delegate together. That was useful for when I was printing it out. It will be useful again if I start to print it out. We're going to keep it for now. So we'll always have a name, and you can pass in a delegate if the name isn't a name in the phases array, phases list. Logic is similar. Starting in 1 second, we say when. So we have an asynchronous background. We have abort. We call the phase function. Now, normal phase functions up here are returning time until the next phase. And it can be 0. It can be anywhere from 0 to 10 seconds. And if you're outside that, I clip it in. In this case, I call this function, which is some sort of background thing to run. And we're going to do the staging this way. And it returns how long to wait until the next one. And that's got to be positive. It could be any positive number, but it's got to be positive. So if it's positive, we set our scheduled time and return true so that kOS will call us back again at that future time. And if one of these things says call me every hour, it's going to do that. and it's going to call you back in an hour. The only thing that's going to stop that is if kOS isn't running. And if I return 0 or negative, a 0 would say call me back immediately, and if I have a function that's saying call me back immediately, it might not get anything else done. So a 0 or a negative number is going to say terminate. So we go back to here, we're using that to start stager. And stager, again, it's a string, so I'm just pulling up the stock standard flight phase called stager, which is a background task. So we're going to call it, and it's going to decide whether or not to stage, and when it's done deciding it, either it's going to stage or not, and then it's going to return a number that says how long it's going to be before the next staging check. And it'll return 0 if it decides it never needs to stage again. Now, BG and Go don't hang out and wait for things to happen. They return. So we still need to have this. If I didn't put this wait until false at the bottom, our main thread would terminate, and kOS would say, oh, you're done, and it would discard all of the when clauses we had going, even though the when clause is doing all the work. So we do a wait until false. So our main thread goes to sleep permanently. We could, for some missions, wait until something else. Terminating the go function, if we let it terminate all the way through, would stop all the background processing. Yeah, there might be use for that. The benefit of this is if we have done some of the stages and we reboot, because we persisted we persisted our phase number, we're going to come in the top and we're going to do persist get phase, and it will pick up the, I'm in phase 5, it'll pick up phase 5 and it continues running. I've tested that and it works. So got all this working, and the last test flight I gathered science on a couple of things, and it was just enough to push me over so that I got the last bit of it so I could put in the launch clamp. And then I realized that if I do the normal thing with launch clamps, which is to stage it like this, where you have the engine and then the clamp, so you stage and the engine goes on, and you stage again for the launch clamp to go on. Well, currently that doesn't work. So we've got a bug. And the reason why it doesn't work, let's find the stager, is stager's basically saying don't do anything until we have reached an altitude of 100. Radar altitude of 100. That's never going to be true. Because we've released, we lit the engines, we never released the launch clamps. We're sitting there pushing against the launch clamp. I don't even know what values these are. I'm pretty sure that my logic here is wrong for this case, because we have solid fuel that we're burning here. It's in phase 4. So the stager is going to need to be modified if I want the stager to be able to handle a launch clamp that's not on the final stage. But that's kind of tricky, so I'm going to leave the launch clamp on the final stage and just kind of remember that that's a thing that I have to do. The alternative is to manually stage in that case. So we would get the countdown, and we would light off the engines, and then the engineer would rush to hit the space bar to tell the launch clamps to release. I don't know, it's kind of hacky. That's hacky enough it will motivate me the first time I need to do that to actually write in something to trigger that happening. The alternative is for the launch phase here to be responsible for all the initial staging. So augment launch so that when launch does here, if available thrust is 0 and stage ready, then it stages. Okay, and it's going to register start time. So we would have to add code right here inside this condition here that says if the current stage has a launch clamp in it, and we're not going anywhere, wait a second, and if we're still not going anywhere, stage again. Okay, so like if we've got thrust and we are literally not accelerating, literally just sitting there, and I'm not sure how to rate that condition. So it would be T shortly after T0, maybe 2 seconds after T0, and our radar altimeter is still below 100 feet. Well, probably better to test our vertical velocity. So yeah, if we're a second or two, if we're several seconds after launch and our vertical velocity is still 0, try staging again. And launch itself happens every 1/10 of a second, so yeah, who knows? Anyway, we'll have to work that out. But with that code, I'm going to do a flight. And I have 1 tourist left to go, and Jebediah's got his orbit star, so I'm going to send Valentina up. She can get her orbit star and do some EVAs. I am not sure where I want to trigger these. I think I've got all of the materials science and other sciences, and yes, E1 now has all of the science. So tucked inside here, I have mystery goo, pressure, and temperature, and I also have tucked in a antenna and a back jeb. And that's all inside that thing, because in any sane world, throwing those on the outside of the rocket would have drag, and putting them inside there won't. And I don't remember whether the current version of Kerbal Space Program models that or not. But if you pull up the science from there, there is a right there. You can see it when I roll down onto it. That's storage for science. That's all clipped together in one big blob. And this is our parachute. So let's let Valentina fly in orbit. I'm going to open up the terminal once I get out there. kOS, open terminal. Thank you. Close the pod bay doors. Okay, so there's what we are printing. So year 1, day 2, 015131, Farkos E/1. So I'm going ahead and reusing the serial number as long as the new microcode for the new embedded code for the new vehicle could run the old mission. That's going to be my rule. If the code that if I modify the code for a vehicle and it can still fly the old mission, I'm going to go ahead and use the same name. Otherwise, we're just making many copies of Go scripts. So, yeah, this has the little teeny engine, which has a really nice performance in vacuum. And I actually have given it about twice as much fuel as it needs. You see, even with all of this science and everything on there, it still has, 1700 delta V vacuum. And we don't have to get very far up from the ground for the ISPs and delta Vs to be more like their vacuum states than their atmosphere states. You wouldn't want to use that engine on the ground, though. Its ISP is really very low at sea level. So we've got Valentina and Rudolph. Apparently Valentina's in the back seat. I have no idea why Valentina's in the back seat, but she's the pilot. Okay, so we pushed our apoapsis up to 81 kilometers. We still have 16 meters per second of delta V. So my rule of thumb is it's going to cost us 1,000 meters per second to circularize with our periapsis that low. If we had a different trajectory, we might be raising the periapsis along with the apoapsis. I think that's more efficient. I'm not sure, but it would be much cheaper to circularize. So earlier I was putting in a reaction wheel. It's still there. So this blob up here, this is a reaction wheel and science storage and the probe core and a parachute, which have all been kind of jammed back into the main rocket. And you notice that if we look at the interior overlay, even though we've clipped stuff back into it, it's still okay. Okay, so there's our activate RCS message. So at this point we are commanding prograde, just chilling. We have 660 meters per second of delta V left, and I can take Valentina out for a little bit of quick EVA. So we have already taken some of the EVAs. In fact, quite a number of them. But the fact that she is out there and doing it is what's important. In fact, I think there's a... Oh, I already did. There was a contract for just doing an EVA, and I got that one done. So we've done our EVA, and I don't know. This looks like kind of a. I don't remember seeing that kind of land before. What is that? That's grasslands. Okay, we'll keep that. We've already got one of those. So MechJeb, if I ask it for surface information, it does have the biome here, so you can watch that. So trying to get science above each biome on Kerbal is a patience game. You just have to wait until you're passing over the biome and get your Kerbal out there and get the science pulled up. That's funny. Did I wonder if I locked my... Oh, I betcha. Yeah. Okay, I set my heading based on prograde where we started where we ended our circularization. But during the wait process, where it's waiting for me to hit RCS, it's not changing that steering, so we are pointed toward the same star. We're just right there, and that's not going to move. If I put this on a time warp, that's interesting. But I don't think it's moving as fast as it would. Kerbal itself is orbiting its sun as well. But I should have been just unmoving. Hold on. Yeah, that's very definitely moving. Okay, well, maybe I was wrong. Anyway, let's bring people home. So that little burst brought us down to our periapsis is now at 2 kilometers below the surface. So yeah, anything below about 30 or 40 kilometers is enough for atmosphere to bring us down. You get down to there, and that's you're seriously bending your course down. But just barely. If there were no atmosphere, we would impact over here. In reality, we're going to be a lot closer, because the next thing is we're going to decelerate. Let's warp forward a bit. I think the current plan is to warp at 40K? 50K. Let's see, phases. Let's see, for the deceleration, yes, between 50K and 40K. So I can warp forward on that one. Okay, so notice at 50K we're starting to get some atmospheric heating. And that's where I have set my default for doing our deceleration burn. And that will last until 40K or we're out of fuel. And we have quite a bit of leftover fuel in this stage, so we're going to slow down very nicely. Now, this doesn't really, change how fast we move through the atmosphere. We're still falling from orbit. But it means that we are going to land sooner. So there's our curve. The other thing is that our parachute is configured to not actually release until we're up to 75% of the atmosphere. And I hope that it's safe, because there's, normally you would have some way of slowing down before then. You would maintain control. You'd have kOS running down through there, so you could wait to pop your chute until you are low altitude and low speed. But we have to get rid of our kOS processor when we get rid of that stage. And I wanted to get rid of that when I was done with the deceleration burn. Among other things, this has a built-in heat shield, which I wasn't using, and now I am using it. So that's better. It seemed like the re-entry had a lot less fire this time. So it is currently safe to deploy, even though I'm moving too fast. I'm wondering if that particular parachute, the radial mounts, might be a little more speed tolerant than the little caps. The 250 knot thing, 250 meter per second thing, is something that I've taken from the little top hat parachute. So we are still pointed in the surface retrograde direction. Oh, wait a minute. Without the kOS processor, we don't have any control over our attitude right now. So this is all aerodynamics. Okay, those booms are my other stages hitting the ground. Okay, my descent rate is 8 or 9 meters per second. This guy can handle 12, I think. It doesn't say on here. I know this is a safe landing because I have done this before. Not in this location. For this mission, where you're going to land depends on where you hit the button to start the landing. Let's speed this up a bit. So when this is set to the mountain, that's radar altimeter. Okay, and here we are. Send Valentina EVA and see if she can get a EVA report. Nope, that one's useless. Board. There we go. Can I get a crew report? That one's useless. Okay. So, recover. Let's see how we did. So we had a little bit of science, and we're back up to 15 science after getting the 90 science I was looking for. We picked up almost no funds, so this rocket sheds basically everything on the way down. So we spend everything we used to build it. And crew, Valentina and Roddorf both got experience. And now if we go look at everybody here, you know, so Valentina can now do a prograde, retrograde hold. So when she is pilot, I can use my SAS button and tell her, please keep us pointed prograde, which would be useful, except I'm running kOS, which I can do that easily anyway. So Bill and Bob ought to do a orbital as well, just to get the experience. I am not sure what happens with scientists and engineers when they get to level 1. Let's find out. I can run this mission really quick. E1. And we are going to use time warp very liberally. Yes, we're spending money to do this. Oh, I ought to at least demonstrate. Oh! No, I can't use time warp. Revert to launch. I am going to demonstrate the reboot capabilities. Apparently there's a lot of torque and stress in this particular airframe. These guys are going to be torquing here. If anything wobbles, this stack is going to get some bendies. So as long as I've got it on 1x physics, we're doing okay. So we're now in the ascent phase. What if we were to reboot? I'm going to get this arranged so we can do a quick power down and back up. So we're running here. Now if I toggle the power, bring it back up. We're in the ascent phase. There we go. Now, if I did it right, we also restarted the stager. And we won't be able to see that for a bit. Can I speed this up during this phase? I'll stop if it gets wobbly. I can go 2x. Can't go 3x though. Okay, so there's stager working. Now I doubt that this bit of the craft is at all wobbly. Yeah, solid as a rock. So remaining delta V 1352, so I wasted some delta V this time. I might give these two guys a chance to go EVA. I don't know whether that gets some experience or not. scientists can boost the value of data from science experiments. I wonder if having the scientist along means I might be able to get extra science out of these guys. Well, not a lot, but some. Let's check the go. 0.1 science. Okay. Transfer. Okay, Bob, have some EVA time. Oh, he got science above Kerbal Shores. How about Bill? We already have the grasslands. Oh, there's one Highlands. Keep. Okay, so we got some science from those. I guess these guys are happy, so we can come home. And again, I am going to use time warp to speed this up. At some point, I will put ourselves in a highly inclined orbit and see if I can get all the biomes. It's going to have to be very close to the poles. In fact, I think it may need to be polar to get the polar biomes. See, there's much more drag effectively on just this part, so he'll slow down more effectively than the engine will. So that engine is just flying off there. If I still had the engine attached, we would be falling much faster, and we'd have much more of a risk that our parachute wouldn't be able to stop us. Making me nervous there, buddy. Well, on 4X, yeah. So Bob and Bill should be able to get boosted to the next level, and we'll find out what that gets for them. And recover vessel. Oh, let's check and see if I got a EVA report here. Nope. Okay, so we picked up some science and recovered some parts, so we still have 176,000 funds. Not much in the way of parts to pick back up, though. And our reputation's up to 198. So, engineer and scientist level 1. This says repack chutes. I think repack parachutes is new. I'm not sure what else is new there. And scientist, vessel science return 105%. Nice. Vessel science and part science returns are increased. And 35% increase in science generation rate. So if we have something that generates science over time, we'll want a scientist along. And we have all these people we can hire, but they're expensive, so we don't hire people yet. And that's as far as I want to go this evening. We'll have to decide what to do next. Probably start gathering, start writing that telemetry gathering stuff so we know how our sequencer we're happy with. We have persistent data that we're happy with. So time to start writing a telemetry gathering system. I have at this point turned off a lot of things. So we no longer have the 100 megabyte kOS things. So we got either 10K or 20K or 40K if we pay to upgrade that one thing until we get more research done. MechJeb is supposed to be only where we have MechJebs attached, but I think I'm getting MechJeb everywhere. I thought I had that turned off. We will not have connection to the archive unless we have a radio signal. So turn that off. Let's see what we got here. Contract parameter complete. Boom, boom, boom. All of these things I finished up. I can delete those. We have no pending contracts. Observational surveys. Test booster at launch site. There's a tourist. These guys want orbits. And the numbers look good. 25,000 funds each. Okay, I'm going to accept that. We've got some in-flight tests and test a thumper at the launch site. Trivial amount of money, 1 science and fame. I will think about that later. And that's it for the night. 176,000 funds. And science. Not enough to go anywhere. This aviation is going to require 45. Once we do that, we can build a non-flying airplane and run around the Space Center and pick up all of the observations from all of the various mini biomes that we can find. Hopefully that will boost our science up so we can start getting in here. But yeah, we're going to need to start getting some serious funds so we can upgrade our base. And let's save the game. And we're done. So, until next time.